everyone, welcome back to my YouTube channel. I am Likita C and currently pursuing my 5th SEM in the Department of Computer Science and Engineering, and today's video is about non-deterministic finite automata. The table of contents are introduction, formal definition of NFA, graphical representation of an NFA, and an example. Introduction. NFA stands for non-deterministic finite automata. It is easy to construct an NFA than DFA for a given regular language. The finite automata are called NFA when there exist many paths for specific input from the current state to the next state. Every NFA is not DFA, but each NFA can be translated into DFA. NFA is defined in the same way as DFA but with the following two exceptions. It contains multiple next states and it contains empty transition. In the following image, we can see that from the state Q0 for an input A, there are two next states, that is Q1 and Q2. Similarly, from Q0 for input B, the next states are Q0 and Q1. Thus, it is not fixed or determined that with a particular input where to go next. Hence, this FA is called non-deterministic finite automata. Formal definition of NFA. NFA also has 5 states, same as DFA, but with different transition function, as shown follows. So you can see that in this function, capital Q stands for finite set of states, sigma is finite set of input symbol, Q0 is initial state, F is final state, and delta is the transition function. Graphical representation of an NFA. An NFA can be represented by diagrams called state diagram, in which the state is represented by two vertices. The arc labeled with an input character shows the transitions. The initial state is marked with an arrow. The final state is denoted by the double circle. Let's see an example. So the set of states are Q0, Q1 and Q2. Initial set of symbols are 0 and 1. Initial state is Q0 and final state is Q2. So here we can see the transition diagram. In the transition diagram, you can see that now let's consider Q0 is the current state. So for an input 0, Q0 can traverse from Q0 to Q0 and Q0 to Q1 with an input symbol of 0. So for an input symbol of 1 from Q0, it can go to Q1. Now come to Q1. Consider it as the current state. So for input symbol 0, Q1 can go from Q1 to Q2, and input symbol 1 is Q1 to Q0. Similarly, consider Q2. So Q2 for an input symbol 0, it can loop itself, that is Q2, and that's it. For an input symbol 1, Q2 has a loop for itself, that is Q2, and Q2 to Q1. Now, this is the transition table. Present state. See, Q0 is the initial state. That's why it is it has a symbol of arrow. And then, so from Q0, input 0 can be traversed to Q0 and Q1. Similarly, from Q0, input state 1 can have a next state of Q1. Similarly, Q1 has an input 0 which can go to next state Q2, and Q1 to next state Q0 through input 1. Similarly, Q2. So here Q2 also has a star asterisk, which means that it is the final state. So in the above diagram, we can see that when the current state is Q0 and input 0, the next state will be Q0. So let us understand this transition diagram with an example. Consider 0, 0, 1, 0. So to traverse that, first let's start with Q0. Q0 to Q1 is 0. Q1 to Q2 is second 0. And then Q2 to Q1 is 1, and then Q1 to Q2 is 0. So hence we have got the final state as Q2, and that's why it has double circles. So hence it is traversed, and this is how it is done. So thanks for watching. Please do like, share and subscribe.